And we should be live now. So yeah, thank you so much for coming along to Not IoT tonight. We have been on a summer break for a little bit, so it's good to be back and see some folks. Hello. Oh, there we are. Before we get going, we've got a strict code of conduct here, which really just boils down to be nice to everybody else. But if you feel as though somebody's breaking our code of conduct, then the easiest way to deal with that is just to send me a private message in Zoom, and then I'll deal with that and keep you up to date with whatever the process of that is. So just generally be nice and everything will be fine. Thanks to our sponsors tonight, my company, PJG Creations, and Tech Nottingham, who are sponsoring us the Zoom license we're using. Calix, who actually I need to go double check because it's been a while. I need to make sure that they're still sponsoring us a piece of IoT equipment. If they are, and we will draw it tonight anyway, then Shorty gets to choose a piece of IoT tech up to like a value of 30 quid or something, and we'll get that sent out to you. That is unfortunately only available for folks in the UK. So do let me know after you've tweeted, but it's the same hashtag. It's not IoT, which I'll show you in a minute. JetBrains, they're still sponsoring us a JetBrains license, and in actual fact, we've got 2 of those to give away tonight. So being as we've got potentially 3 prizes, you're in with a really good chance of winning one of those. Being as there's Shorty can't really win it, and neither can I. And then there's 7 more.
I already have a paid one anyway.
Fair enough. Yeah, well, you can have it for free. Sure, we can work something out. So Tech Nottingham, I just mentioned those. They're sponsoring us the Zoom license. They're one of the biggest and best tech meetup groups around, based in Nottingham, but actually they're all over the place now. They're not going back to in person, it seems, which is a shame. Look at that photo. It's a bit disappointing, that news is. Whether that'll change, but I think that's partially driven by the fact that Andrew and Emma have got a little baby now, so I guess their motivations have changed a little bit. But either way, they're still a fantastic user group. They're a virtual one at the moment, so do go check them out. Join their Slack channel. It's got channels in there for pretty much anything you want. As I mentioned earlier, tweet for swag. So absolutely we'll win a JetBrains license. I'll send that as a DM to whoever tweets on the hashtag NotsIoT. We'll draw that after NotsIoT and then sometime in the next couple of days. They keep emailing me telling me that I've not used enough because I've been off for the last 3 months. So that's why we've got 2 to give away tonight. So do tweet on the hashtag NotsIoT. And then Calix, I need to email them and double check. I was going to do it earlier, but then I ran out of time. But theoretically, they're sponsoring us a piece of IoT tech that Shorty will choose, and I'll still draw that, assuming that we're allowed to do it. If you'd like to become a Microsoft MVP, and I don't know if there's Stefan, are you an MVP? I can't remember.
Fingers crossed, not yet, but let's see.
Yeah, and Steve, you're going through that process as well, aren't you?
Yeah, I'm just waiting to hear.
Yes. So this is, if you've not heard of it, this is a program that Microsoft allow folks into that are good in the community, and they help, and they do talks like Shorty's doing, or run user groups like I do, or create content or attend events and help and do things like that. So there are obviously some benefits with that. You get insider news from Microsoft before other folks do, and you get access to free software and things like that. So if that sounds like that's something interesting to you, then do get in touch, and I'm more than happy to help you along with that. I'll probably just give it to Jess because she seems to do all of their MVP work at the moment for getting new MVPs. She's awesome. So tonight we've got Shorty, or Peter Shaw, as he's otherwise known, talking about low-level USB with .NET. He gave me a very quick demo of this earlier, and actually it looks pretty cool. So I'm looking forward to that. Describing himself as a technologist, and I added on Pluralsight author. Because actually, until the other day, I didn't realize you were a Pluralsight author, Shorty. So
yeah, I have been for 12 years now.
Yeah, there you are. I say I'm only 4 years, so you're way ahead of me. Coming up next month. Now, this date might change because it turns out actually that's Microsoft Ignite that day. So I'm actually going to be up in Manchester. There's a UK event up there for Microsoft Ignite, and I think I'm up there for that. So I can still do this, but I'd be in my hotel room doing it. But it might be that this gets switched to 2 weeks after that, because actually I'm on vacation the week after that. So I don't know. But anyway, Octo Everywhere, if you've ever heard of Octoprint, then you'll know what this is. But essentially, if you've got a 3D printer, Octoprint is a piece of software that allows you to control your 3D printer from your PC. And Octo Everywhere gives you the facility to be able to control that 3D printer from anywhere. You could open up ports on your machine and stuff like that, but that's generally not the best idea. Safety first. So actually, this works on a socket-based system as far as I can work out. So far safer for your network. So hopefully we'll have some information about that next month. This is all written in .NET. Octo Everywhere is. So it'd be interesting to hear about how that works. As it's going to be, that particular talk here is going to be less .NET focused and more IoT focused. And then in the new year, the same chap is going to come and talk at .NET Knots, and it's going to be more about the .NET elements of that. So more information on that coming soon. And I mentioned earlier on, before we started the call, that on Monday we're going back to in-person at .NET Knots. It will be hybrid because I don't want to cut off the folks that are joining that can't travel or have come from afar or something like that. But Gosha Borcheska will be talking about Azure Cognitive Services and going through all the different offerings that they've got. If you're interested in coming to in person, we'll be at BGSS in Nottingham on King Street. But if you can't or you'd prefer to join on Zoom, then you can absolutely do that just through Meetup as well. So do come along and have a look at that. I mentioned this course every month, and actually some sad news. This is going to get retired out of Pluralsight in December, which is really sad, especially for my bank balance. It turns out that Pluralsight have bought a Cloud Guru, which is another company, and they've got a similar course to this that isn't as good. It can't be. It's not got me in it. And they've decided to keep that instead of ours. So disappointing. But until then, you can absolutely still go and watch this. And it's been nice the last couple of months listening to folks that have used this content to pass the AZ220 exam. Well worth doing if you're into IoT and you want to take your career to the next level, pass that exam. Okay. And we are now back live with IoT Live every Tuesday night at 9 p.m. BST on the Azure-ish Live Twitch channel, where myself, Cliff Aegis, and Maria Mustaka, we discuss all the IoT news every week. So it's just a bit of lighthearted fun, really, and going through all of the stuff we've found on the internet. And then do check out the Agile Engineering podcast if you're inside the DevOps community, then you might find that interesting too. And don't forget, it's Hacktoberfest coming up next month. So go contribute to some open source projects next month and get yourself the opportunity of getting a t-shirt or planting a tree, I believe, is the other alternative. That's well worth getting involved in that for the open source community. And with that, we will stop sharing and let Shorty do his bit. So thank you very much.
As I was just going to say there, you were on about your Pluralsight course being retired.
Yeah.
It doesn't mean that you won't get paid for it. It just means that it doesn't appear in the search engine.
Yeah, which sucks.
So anybody who's shortcutted it or has a link to it and gives it to other people to watch, you will still get the royalties off it.
This is true. I imagine the numbers will go down considerably, sadly.
Oh, indeed. While I'm on the subject of Pluralsight, I think I will just let people quickly know I'm in the midst of doing a new ASP.NET 6 one. Hopefully, it should be out by the end of the year, and it's going to be all about extending ASP.NET 6 and the different hooks and different places inside the framework where you can basically hack in your own bits and pieces and extend ASP.NET to your own liking. Right, let's get started on this. Can everybody see that screen? Should be able to see my slide yet. Excellent. Right. If I do lose my mouse pointer or anything, please bear with me, because I have, as I described it to Peter, I have a triangle setup of monitors here. So I've got to go sort of down, across and up to get to another monitor and things like that. So it occasionally takes me a little bit of effort to get to where I need to be. Right then. There's a few of you here who know I am, some of you who don't. So just briefly, I'm one of the people responsible for running the .NET user group, LidNug, on the LinkedIn platform. my other co-conspirators hiding in the crowd amongst you there. We've been going, bloody hell, how long have we been going now, Brian? Is he there? No, he's gone. I think we've been going for about 15 years now. Anyway, something like that. We were basically doing online .NET presentations before COVID or anything caused anybody to stay indoors. Code for this session, I've put it up on my GitHub page. Shorty low-level USB, and in there you will find the source code, you will find the data sheets, and you will find an absolute treasure trove of FT232 related programming documents and application notes and things like that. If you want to drop me an email, feel free to do so, Google Mail, or you can stalk me on Twitter. My handle's there, shorty_DS. Right, how many of you recognize these things? Now, we've all got a plethora of these in our IoT toolkits, and we use them for connecting goodness knows what. If you recognize them, you'll usually be using them for something like USB, TXRX on an Arduino, serial console on Raspberry Pi, that kind of thing. In my case, I tend to use them for hacking into devices such as TVs and routers and such like. But what a lot of people don't realize is these things can do way more than just standard UART serial communications. Most people buy them for the intended use, RxTX. And they usually just solder on the 4 pins that they need on the end. If we go back to the picture here, you can see in that one, it's got the 4 pins on the end, which basically are just your RX, your TX, your +5, your ground rail, and possibly a control line or two. And most people leave it at that. Few jumpers, bit of breadboarding, job done. However, if you look closely at the underneath and on any of the ones that you might have, and if you've got some in your toolkit, go and grab one and have a close look at it. You'll see that many of them have these rows along the side. Now, in the case of this one, you've got your DCD, your RSD, so they're your data carrier detect, your data terminal ready, that kind of thing. You can see your RxD and your TXD are repeated, but you've also got the likes of RI, ring indicator, your RTS and your DTS, your TXL and RXL, which are for the lights. So if you've had like a serial adapter and you've seen the lights flickering on and off when data's going through them, they're normally connected to those RXL and TXL lines. The smaller boards, so the reason they have all of these, especially on these smaller boards, is because these chips are not just a standard USB to serial adapter. They're actually a serial processor, more like a CPU, in fact, than an actual bridge chip, if you like. In the case of these small red ones, the chip that's usually on them is an I2C FTDI is the manufacturer of Future Technologies. Now, the reason the serial processor on these is so useful is because all of those individual bits can be toggled separately under software control. You can set them to be automatic, so things like the lights flicker in time with the serial data stream going through them and such like that. But you can also take complete control of them. So if you wanted to use those two light lines, for example, as two GPIO lines, perfectly able to do so. And through various software means, which we'll see shortly, you're able to turn them on and off directly, and you're able to do pretty much everything that you might traditionally use something like an Arduino or an ESP32 for. Now, that allows us to do some interesting bit banging scenarios. So what is bit banging? Well, despite how it sounds, if you have control of the GPIO lines and you can turn these things on and off fast enough, then you can create complicated protocols by doing different combinations of on and off levels, +5, 0 volts. In the case of the Arduino, if you've ever used the software serial ports, that's bit banging. What you've been doing there is you were bit banging a UART protocol. For those of you who have tried to use the loop in an Arduino to do PWM on a non-PWM pin, again, that's a form of bit banging. The FT232R allows you to bit bang, but without any complex software. It behaves very much like a CPU. Any of you who've done old 8-bit programming, like myself back in the days of the BBC Micro, Spectrum, things like that, 6502, 6809, you'll be familiar with sending opcodes or machine code directly to the CPU to talk to it in its native language without using a high-level language. Well, the 232R serial processor works in a very, very similar way. The documentation that the manufacturers FT make available is actually really, really very, very comprehensive. And it's probably one of the best sets of documentation I've seen for any of these devices anywhere on the market. They really do go into very low level with the opcodes, the commands, timing, things like that. And generally you have commands such as clock in, clock out. So you buffer a byte to the chip and then you say, clock this out at this frequency. And it will do all the hard work of toggling the clock line at the speed that it needs to and making sure that the byte that you've given it goes out a bit at a time without you having to worry about any of it. Hopefully everybody here is familiar with I2C. But for those who are not, we'll just have a quick run through this when I find my mouse pointer. There it is. So you typically start with a start condition. I2C is a 2-wire protocol. One wire is a data line, the other wire is a clock line. And you typically have a start protocol, start condition, sorry, get it right. And you can see that that drops from +5 down to 0, just ahead of the +5 to 0 on the clock line. And then every time the clock line pulses, you clock in a bit from the data that you're sending to I2C. I2C addresses devices with an address number of 7 bits and then a flag that sets read or write, and the device will then acknowledge that and tell you whether that particular address was responded to or not. And this kind of complex protocol is built directly into the RS232R to a certain extent. You'll see shortly that there's a better way of doing it with the the 232 chips, but I don't want to spoil the surprise. Using the clocking commands on the 232R, you can give it this byte and then it will clock at either 400 kilohertz or 100 kilohertz, and it will produce that exact waveform to represent an I2C bus. And this is exactly the same type of I2C bus that you would get if you connected an I2C device to, say, a Raspberry Pi or an Arduino or something like that and started talking to it with the various communication bytes on that. And I'm jumping ahead of myself because I've already said everything that's on that slide, haven't I? So the manufacturers that produce the FT232 provide a complete SDK for all of this. The SDK is called D2XX. Now, I have no idea why they called it that. I think originally it was called D2 Serial, and then they started producing better devices or something, and, well, naming is hard, as we all know. So it became known as D2XXX. And all this can be downloaded from the Future Technologies website, which I have. No, that is, okay, let me go back a slide. Let me go back 2 slides, in fact. Now, let me find my browser. Just bear with me 1 second. There it is. If we go and have a look around on Future Technologies website, you can see some of the examples that they provide. For example, here, we've got the do a library called libmpsse, which unfortunately is not yet in .NET form, but they do provide the source code for it, and that is a C++ DLL, Windows native, which can be compiled. So I guess it wouldn't be too difficult to put a .NET wrapper on it. But you can see there as well that they also provide samples for things like JTAG and direct USB to I2C bridge. I'm not going to read through all of this. I'll just sort of have a quick rundown. The amount that's here, it's just, you can spend an entire day going through it all. The one we're interested in, however, is this one here, USB to I2C. And they even provide PDFs with the source, not only the source code, but the circuit diagrams for you to test this out. Now you can see there, that's a 2232C. There are a variety of different devices in the FT232 range. We'll come back to that shortly. Cripes, I've lost my, there it is. I thought I'd lost my mouse pointer again. Right, so now, while all of this looks really great, and it's all nice and neat to play with, and it is fun, believe me, it's ridiculous fun, being able to just plug this stuff directly into your USB port and make it do stuff. The FT232R that you normally get on these little red devices has a very, very serious flaw in it. It's got a very serious timing bug. Now, I don't know how well that image to the right shows, but this YouTube link here will take you to a video by a chap called Scott Harden. And it's the only video that I've ever found on YouTube that goes through any of this process and explains any of what I'm doing here now. And in his investigation of the chip, you can see that he has this rather insane trace here. Now, if you look at the clock line is very, very, very irregular. You've got some pulses short, some pulses are longer than others. And that makes for a very, very unhappy I2C transaction when you're trying to talk to things over a physical 2-wire bus. And Scott basically discovered this, and he went back to FT and he explained it to them. And Future Technologies said, well, you know, how's this? They gave him another chip to test it with, and this was the trace that he got with the new chip. And it was at that point that Future Technologies announced that the solution to the problem was not to fix the silicon on the FT232R, it was to build a completely brand new chip. So they came out with this, the FT232H. And boy, oh boy, is this thing something. You'll notice when you look at it that the chip is more square for a start. It's not sort of the little USB form factor like the one on the small red UART adapters. Also, it's an actual USB female plug rather than a micro USB. Sorry, it's a USB male rather than a USB micro female. The FT32, the 232H has been completely redesigned from scratch. And this new chip that's on it is a completely new serial CPU. Streets ahead of anything that was on the older UART chips. And I'd be here all night if I tried to explain the entire instruction set to you. They've basically called it the multi-protocol synchronous serial engine. Now, it's also very fast. 60 megahertz crystal on it, which I know doesn't seem very fast when you compare it to something like a 1.7 gigahertz Raspberry Pi or similar. But this is capable of doing an 800 kilohertz I2C bus. And the standard fast protocol in just about anything that uses an I2C bus currently in use today is only 400K. And I reckon if you got the clock devices right and pushed it even harder, this thing could probably clock easy up to a megahertz without breaking a sweat. If you look on the underneath of the board, you'll see that the 2 rows of pins are no longer labeled things like RTS, CTS, RXD, TXD, and all of that kind of thing. You'll notice that you just have AC and AD. And that's because as far as the new serial processor is concerned, all it has on it are 2 very, very high speed parallel buses. Now, any of you who have programmed a PIC microcontroller, in fact, no, not the PIC microcontroller, the Raspberry Pi Pico as well has it, will know about the, I forget what it's called, the automated pin logic, where you can set a pin up to provide certain signal sets without bothering the CPU core. So the CPU core can be left to run other things and the logic on the pins will just run themselves. Well, it's a very similar thing on this, but that is all this device is dedicated to. You basically send a control byte that says, make AC8 an output and all the rest an input, and then write GPIO pins 9, 7, 4, so on and so forth. You know, it's all individually addressable. Now, in terms of what we're doing, yep, I'm ahead of myself again there. I really must learn to read my slide previews. For what we're interested in, serial-based protocols, however, SPI and I2C, the important pins are these 3. AD0, AD1, and AD2. See that I've marked them on there, green, yellow, and blue, respectively. Now, if all you are doing is serial, if all you are doing is hooking I2C devices up to your PC, or in fact, anything else that a USB device will plug into, doesn't have to be a PC, then you have 10, so what we've got there, AC0 to AC9. So there's 10, 11, 12, 13, 14, 15, 15. You have 15 other pins that you can use as general purpose I/O at the same time as you're running an I2C bus or an SPI bus or a UART off that thing. Now, something to note, however, is that you have 2 separate pins. You have a serial data in and a serial data out. Now, that makes a lot of sense when you consider that this device is asynchronous. And asynchronous is because it's technically designed first and foremost as a UART. So you have your TX and your RX at the same time. And if you were doing SPI, you'd have your MSIO and your MOSI to the lines. I think that's the right acronyms for them. So if you're using one of these, you will probably have to build a small Y cable. Now, I can't show you the one that I've got here because it's wired up to my circuit at the moment. But what I basically did was I took 2 small jumper cables and I cut one of them in half. The one I cut in half Well, I cut them both in half, sorry. The one I cut in half, I soldered both of them onto half of the other one so that I've got sort of a little Y cable and then put a bit of heat shrink around it. A suitable circuit to wire this up on a PC is basically as follows. Now, if you've done anything with I2C before, you'll know that you need to terminate the bus usually. If you're just connecting one device straight to this, then you don't need the pull-up resistors. But if you're putting multiple devices on here, as I have with the breadboard example you'll see shortly, you will need a pair of pull-up resistors to pull it up to 5 volts. And that's because the I2C bus by default is in a high state. Rather than like most buses, it doesn't pulse from low to high, it pulses from high to low. So pulling the lines up is basically idle for when there is no communication going on the protocol. It's always wise to have the pull-up resistors, even if you have only one device on the line anyway. Now, a little bit of a warning, buyer beware. With a device this popular, it'll come as no surprise the Chinese markets are flooded with clone devices. This one's a CH341A. I have one downstairs. Now, don't get me wrong, it's quite a capable device, but that CH341A chip that sat on the board there, if you notice closely, it's the same footprint as that one. Yep, because a lot of these Chinese devices are actually rebadged 232Rs. So they have the timing bugs on them that the normal 232R has. And, well, it's Chinese as well. So you never really know what you're getting when you buy it off places like that. If you do get a good one that's well made, you can pull some quite clever stunts with them. But despite what the listings tell you, they're not the same as the FT232H. They are more like the 232R in respect to anything else. They do have an SDK when you manage to find it. You've got to go through the, sign the, you know, the various contracts and things with the Taiwanese manufacturers and the non-disclosure agreements and all that lot. And when you do get it, they absolutely will not give you an English version of it. It's a Chinese version and you better learn to read it. I know this because I went through that pain to get the SDK myself, and I've only ever once seen a couple of pages out of it that another maker had bothered to translate themselves and put on the GitHub page. I cannot since remember which GitHub page it was on. If you do a search for the CH341A on places like YouTube, you will find a lot of them badged as EEPROM programmers. Most of the EEPROM programmers that you see the car enthusiasts using for hacking their ECMs on the cars and hacking the TVs and the routers and putting open WRT on, things like that, are driven by these. And most people associate them with the EEPROM programmers that they're built around. So if you go to order a 341A, you do need to be careful because there's a very good chance you will end up with an EEPROM program and not an actual prototyping board like that. And at this point, I was expecting to have, or to be going for a break. Pete, are you still there? Are we doing a break or not because of your prior pub commitments?
No, carry on. You go ahead.
Okay,
yep.
No worries.
We're all good. Yep.
So let's assume that the breaks happened. I really should have brought a glass of water up here as well. Okay. Give me a second while I reorganize things on my screen. Now, I need to stop sharing the screen if I'm going to do the overhead camera, don't I, Pete? So unfortunately, what that means is if I can't have my camera on at the same time as the screen share, then I am
You know what you can do? You know what you can do?
What's that?
You could use the Windows camera app window and drag it onto the screen.
Couldn't I? I could. Yes, I could. I could. I could.
There you go. The box. We're outside of it.
Right. I've got my finger over the stop share button, so I'm just going to stop that screen share for a moment.
You didn't need to do that. Unless you were sharing a window rather than a screen.
I did actually, because the damn thing was on my top monitor right over the top of this title bar. So I couldn't actually click on the window that I wanted to move.
Don't.
As happens.
Mm-hmm. I didn't realise my camera's been off that whole time.
Yeah, we thought you were just hiding.
Yeah, no, sometimes for some reason, I think because it's like it's one step under an SLR, this thing with an HDMI output, and it goes through that Elgato interface, the HDMI interface, which eludes me. And sometimes that freezes and decides that it's going to turn off. So
gotcha. Right.
I'm here.
Yeah, I'll switch back to that screen in just a minute. There we go. So we'll have a quick dash through the code first. Damn it, I've lost my mouse pointer again. There it is. Guys, if you're ever thinking about doing presentations yourself, stick to 2 monitors. Right, there we are. Okay.
I can't see your screen share, by the way, Shorty.
It's coming back, I think.
Yeah, it's coming back now.
There it is.
Right. Everybody see that?
Yep, it's backwards compared to what you showed me earlier, just in case you didn't realise.
Yeah, it's so let me explain why that is. So this app here by Saley Logic is a rather wonderful piece of software, as you saw, but I don't know how the hell they've written it or what they've done with it. It appears to be WPF, but the window furniture does not behave the same way as any Windows application I've ever seen. The maximize button basically makes it go max screen, but you can't minimize it. And you see that little drag down in the corner there? You can only resize it from that corner. You can't resize by dragging any of the other borders around the windows. So it's easier to put it on that side because I can just go full screen, plonk it against the side, and then drag it up to halfway across the screen.
Feels like my Archimedes. That's exactly the same on there. You'll know that.
Yes, absolutely. And I still think that Riscos has a lot of clever tricks to teach Windows.
Yeah, the memory allocation, I think, is probably my favorite thing.
Yeah. I like the filer icons as well, but
yeah, agreed.
Let's crack on with this anyway. So I've got it on half the screen at the moment here because what I actually want to show you guys is just some sample code that uses the 2D XXX library to do all this. So before I dig into the code, I'm just going to show you it running. Now, let's just have a little poll here. How many of you have got a logic probe?
Other than the microchip IDE with its built-in logic probes, my ICE device, no.
Yep. Well, I actually have a Saley, well, it's not a genuine Saley logic. It's a Chinese knockoff, but it's an 8-channel 48 megahertz. And because it's a Saley knockoff, it means that I can use the official Saley software with it. So hence why I get to use this. And when you're working with stuff like this, this is an invaluable tool to have. Obviously, you'll see it hooked up on the breadboard shortly. But as I was explaining to Pete before, what I've got here is I've got a trigger set up on that first channel there. And that's a falling edge trigger. So what that is essentially saying is I can start that logic probe going, but it will do absolutely nothing until it sees a signal transition from +5 volts back down to 0 volts. And it has to be that transition. If the signal is stuck at 5 volts when I start it, or the signal is stuck at 0 volts when I start it, it won't do anything. it has to see it go from 5 back down to 0. Now, as I mentioned before, because I2C is a positive bus protocol, you have to drop from plus 5 volts down to 0 volts to do a start bus signal to start scanning the bus. So the probe essentially is going to wait for my code to do a start bus, a start condition signal before it starts scanning it. Now you'll see also as well that I have an I2C Analyzer here. And if I just open the settings up for that, okay, that's not what I expected it to do. Oh, there we go, edit settings. So you'll see that I have SDA set to channel 1 and SCL set to channel 0. Now, if you think back to the diagram that I showed you just a moment ago on the slides, and the little Y cable connecting pins 1 and 2, pins 1 and 2 are the SDA channel. So pins 1 and 2 are hooked up to this input here, the brown input on the logic probe. And then pin 1 with the clocking signal is hooked up onto channel 0 on the probe there. So we'll set that away running. Now, the reason I've set this away running first off is because if I press that, this actually shows that it's setting the chip up, but not doing anything on the chip's data lines. Yeah, you can see it's still sitting there waiting for something to happen. Because even though I've programmed the chip to do I2C, I haven't actually put any I2C traffic on the bus yet, and thus none of the devices that are there sat on the breadboard realize that anything's going on. Now, if I just F10 that, and you watch closely, you should see the logic probe will spring to life. And there we go. So what you're actually seeing there is the bus being scanned via that FT232H, and it's enumerating every device from 08 through to 7B to find devices on it. And we'll just stop that for now because this is now waiting. And if I F10 that next call in the code, you'll see there, hands up anybody who's done I2C on a Raspberry Pi, you'll recognize this. That's actually the I2C, the little command line I2C Python script that does an I2C bus scan and displays the contents of the I2C bus. But that is directly on my PC's USB port. There's no Raspberry Pi or Arduino taking part here. For those of you who are curious, that device 20 is a 16-channel GPIO chip, MCP2717, I think it is, something like that. 27 is a 4-bit OLED display, and 48 is a TC74 temperature sensor. Now, if I continue to go down through this code, what we'll do, just so you can see it, I'll shrink that down a bit. Now, I apologize. I didn't have time to write any driver code for the GPIO extender because I had a few hassles getting some bugs ironed out with the I2C setup. But I do have a device driver built into this application for the OLED with an I2C backpack on and for the temperature sensor. And you can see there, if I F10 through that, it'll pick up the fact that it's found it. And, well, that's just my driver for the LED display. And if I now find my camera app, there we go. Now, I don't know how well you can see that. And there you go. There's your little OLED. And that is powered directly off the U. In fact, you can see from the overhead camera there, we'll come back and look at this in a bit more detail in a moment, but you can see that
You can't see your overhead camera. We can't see that.
Oh, of course you can. I've got it on the wrong bloody display, haven't I? Muppet.
I liked how everyone was like so polite and didn't mention it.
Folks, feel free to call me a Geordie Muppet if you want. I've been called worse.
A Geordie Muppet's different to regular Muppets?
Yes.
Okay.
Unfortunately.
Cool.
Right. Let's rewind that back a couple of minutes. I'm disappointed in you, Mr. Collins.
Surely.
Say again?
Worse was you called the Mac and Muppet.
Well, you see, you'd know that though, Graham. Yes, so we'll rewind back a couple of minutes. And there you go. You can see, hello there, .NET Nots IoT. Or you should be able to. Can you see that? Yeah. Now, you can see the absolute rat's nest of wires and that's there. There's not an Arduino or anything in sight. It's all just pure USB. Everything is plugged into that hub. But we'll come back and we'll have a closer look at that in a minute, because I'll sort of dig in and show you the wiring. Likewise, if no, I don't want to. Okay, what happened there? Give me a second, folks. I think I've just huffed JetBrains.
He's broken it.
Yes, that's something that doesn't happen very often. Takes quite a bit of doing to upset Ryder.
Yeah, but you breaking things is something that happens quite often.
Oh, for sure. I make a habit out of it. I mean, it's what I was put on this earth for. Right, there we go. So yes, my OLED displays just flickered at me there. There we go. And the last two bits on that, you saw those reads there. So the temperature register on the temperature controller reads 20. 2's complement those TC74s, so that 20 is without the bit 128 set on it, which means it's 20 degrees C here in my workshop, which is just a nice comfortable temperature. Right, so if we spin that out a bit more and go back to this. Can everybody see that code okay?
That's good.
Yeah. Right, bring the Explorer back up. So the actual the actual .NET library that FTDI provide for programming this thing is unfortunately still just a .NET, old-fashioned .NET 4.8 assembly. However, what I've done is, with the magic of I2C, I've reverse engineered the thing, rebuilt it, recompiled it, made a couple of changes to it so that it now compiles under .NET 6. And if you look in the repo that I've put on GitHub with sample coding for this, you'll find that folder there. Everything in there is exactly the same naming and exactly the same call structure as is in FTDI's documents. So instead of going and downloading the DLL, the .NET Wrapper DLL from FTDI, you can just drop this folder into your project, and then as long as you've got the FT2XX driver for the actual COM port on it, everything should just work. Now, if you've plugged one of these devices in and you've let Windows install the default drivers for it, one thing that Microsoft have got right is that they put in automatically not just the serial port drivers for Windows, but they do copy in the D2XX DLL as well, 64 and 32-bit versions. So to actually get the C DLL that this code backs onto, all you need to do is plug one of these devices into a USB port. let Windows do its special stuff. And then after that, with that folder and the code that I've ported across dropped in, it'll just talk to your whichever FT device you've got plugged into your USB. The class that you're most interested in, or the one that you will want to instantiate to use, is this one here, ftdi.cs. And that basically is the one that does most of the donkey work. Now, yes, the code is ugly, and there are a couple of spaces in it where it's using some unsafe. When I get 5 minutes, I'm going to try and tidy it up a bit. I will probably even release it as a NuGet package. But for now, yes, it works. It's just very, very ugly and very, very unwieldy. But reading through it gives you a really good appreciation of just what the chips are capable of when you've got them on those boards. As well as that, I've also provided a couple of utility classes for you. So you'll see here you've got this I2C one, and that basically gives you your low-level I2C sort of communications. Before you use it, you have to new a copy up. I've not tested this with the .NET dependency injector. So if you want to test it, be my guest. But in theory, because all of this is in user space and none of it constitutes kernel code, all of this should, in theory, just work under an ASP.NET web application on a standard server operating system without anything special being done. But you need to make sure that you new that up, and you need to make sure that you pass that FTDI device in. This reset and configure can be a little bit temperamental. The way FTDI have chose to do this is to wake the chip up. You have to send some deliberate bad commands to the chip. Think of sending illegal opcodes to an old 8-bit processor, something like that. Those of you who did BBC and C64 program will know exactly what I'm on about here, to do odd things that the manufacturers never designed them to do. So in this case, to actually reset the chip and put it into a mode that's needed for I2C, you have to send 0xAA and 0xAB bytes to it, and then test what it sends you back. Now, in practice, what I've found is the first time you plug the device into your USB, and the first time that it's been powered up, that will go wrong and it will throw. But if you then run your code again, it just works fine after that. If you unplug it and plug it back in, the first time you run it, that will throw. It will get the wrong exception. From the people that I've spoken to at FT, it's apparently some kind of settling time. You've got to let the chip settle for so many milliseconds after you've made certain calls and things. And you can see here that I've got like a 6 millisecond delay there after sending the general general reset commands to it. But other than that, that's really the only problem you're going to get with it. As well as the I2C interface, I've also provided some driver code there. So we've got this here for the, no, that's the GPIO one. We've got this one here. That's for the 4-bit OLED. So everything you have in there will power one of those Hitachi displays with a 4-bit I2C backpack on. And there's also one there for the TC74 thermal sensor. Now, the good part here is, because the I2C the I2C code is quite simple, the way I've done it, any of the driver code that you get from the nano.net project, if you haven't seen it, it's .NET that runs on an ESP32. Any of the driver code that they have for the devices there should be possible to port across to this, and just sort of change the I2C interface. And that's largely it for the code. It's all there on GitHub. It's not stupidly complicated.
I'll put a link in the chat. I'll put a link in the chat for that.
And I'm aware that Peter's chomping at the bit to get down to the pub. So we'll go back to the camera and I'll take you on a whistle-stop tour through the circuit board. So that is not actually wired up to anything at the moment. That's the 232. Now, what I was actually going to do is I was going to put a couple of LEDs on the back here, as Scott Harden did in his video, but time being what it is and running out, then I didn't get around to doing that. But you can see that they are very, very simple. I also have one of the Chinese ones here, so we can do a quick comparison. So there's the Chinese one, that's the CH341. You can see they're very similar in the form factor that they've got, but they try to pass those off as 232Hs when they're not. Down on the board here, so you can see there, you can see that all right, can you? Yep. So those two lines there, that's the SDA data, and they come through with the same row of pins here. So technically I've joined the send data and the receive data together, as I explained before. And the grey ones there are the clock pins. So that's the serial clock. And then from there, you can see I've got the SDA lines coming down to the GPIO chip there, the temperature sensor there, and of course, our OLED here. Now, you remember I mentioned I'd built a little sort of Y adapter. So I'll just pull that off there. You can see that that will save you a lot of grief if you're working with I2C on a 232H. That'll save you a hell of a lot of grief, especially if you're connecting stuff up that hangs off sort of a pigtail like this. So we'll get rid of those powers there. Just get that out the road. Now, over in the far corner, let's see if I can angle that a bit better. I don't know if I can. That, come on, move it, damn you. That little block in the corner there, just tilt it up. That's where my logic probe's plugged in. So you can see that I've got the serial data on pin 2, the serial clock on pin 1, and I'm not actually using the clock line on the logic probe. But if I reach back here, let's see if we can bring this into footage. That's the actual probe itself. Now that I picked up off, I think it was Amazon, cost me about £5. And the actual official Saley logic costs somewhere in the region of 120 quid. And this can pretty much do everything that the standard Saley logic can. Cheap enough that you can have a whole box full of them and have as many lines as you need. What I did with mine was I pulled an old serial cable out of a PC case, which just had the right size plug on to fit in the end of it. And then I IDC crimped some connectors onto the end, and hey presto, it's great for working with the various boards. The LED, in case you're wondering, is just to remind me when it's switched on. A nice trick, actually, that I know quite a few other makers do. With their boards, they actually have like an LED and a resistor just built into the board there. So as soon as they put power onto the breadboard, that lights up and they know that the power rail's alive. I'm not that sophisticated. I'm just a Muppet Geordie, so, you know. And like I say, it's really not a complicated circuit. It looks more complex than it is, just because I've got jumper wires everywhere. But again, GPIO chip, there's the power line. There's the serial clock. There's the serial data. And if I send the bytes, when that's wired up and detected, if I send the bytes to it as per the data sheet that is also in the GitHub repository that I've provided with the code, these 8 pins here and these 8 pins on this side become a further 16 GPIO pins. And as if that's not enough, you'll see I've got these 3 lines over here all connected to 0. Well, they're connected to the address lines on the chip. So at the moment, they're all on 0, giving it an address of 20, but the 7 different addresses that these GPIO chips can respond to. So I can sort of set that to there and put it on 21. Put all 4 of them forward, and that device now comes on 27, which I couldn't have it on 27 because that's where my OLED is. But the reason I'm pointing that out is because that GPIO chip there, you could, in theory, put 7 of them on the board with 16 IO lines each and drive them all off this single USB connector. So I'm not even going to do the math on that. I'll let Peter do the math on that if he wants to, but that's 7 times 16 GPIO pins, and you still have 15 on the FT device itself, plus your I2C bus to hook anything else up to it I2C wise that you want to.
The answer's lots, by the way.
Yeah, there are lots. Yeah. Well, yeah. You saw that Crackers circuit diagram that I put online, didn't you? In fact, if I'm not mistaken, I did actually blog it, I believe. I don't blog anywhere near as much as I should these days, really. Oh, there it is. So for those, oh, that's interesting. Why is that graphic missing? Must just be an online one. This post that's on my blog was originally done when I did the first version of this. I think it was February last year, wasn't it, Pete? When
somewhere
I did this,
yeah.
But the reason I chose to redo it is because my camera work in the first version was absolutely abysmal. You couldn't see anything on the circuit boards. You couldn't see anything on the OLED. So hopefully much better picture this time. But there you go. There's the rather mad diagram that I was looking for. That is what 16 GPIO pins piggybacked off a single I2C bus looks like.
Mental. Obviously, you're not going to be doing high-speed switching this way, but it's perfectly great for reading inputs, slow-speed inputs, and turning LEDs on and off.
Yep. And we'll leave it at that point, I think, Pete.
That was really good. I enjoyed that. It's funny to see I2C being used on a PC. That's it breaks my brain looking at it. It's like, oh, that's cool. I like that. So yeah, definitely something I should look at in the future. and have a
Well,
play
you
with
know,
that.
if you want, Pete, you're always welcome. Once I get the YouTube channel up and running properly, Shorty's Workshop on YouTube, by the way, if people, if you don't mind a little bit of self-promotion.
Oh God, no, absolutely.
Once I get that up and running properly, and I start putting out regular videos and things, you're more than welcome to come on and do a bench hack with me or something like that.
Yeah, I'd love to.
You know? Same
definitely.
goes for anybody. I'm more than happy to have people come on. One of the things I actually want to do with the channel is to have regular makers and regular people in the PC and the electronics sort of industry come along and say, well, you know what? I've been trying to figure out how can I do this? How can I do that? And we'll come along and I'll work it out and we'll do a bench session, maybe you by Zoom and me broadcasting, and we'll figure out how to solve your problem or how to build the gadget that you want. And just to give you an interesting teaser as to some of the things that are coming, I have underneath this bench where I am standing an old 1980s separates hi-fi setup. And that lot is going to get converted so that it can be driven off a web server with its own REST interface. That's going to be fun. Now you know why I need 16 times 16 GPIO lines. Any questions?
I think everybody's mind's been blown. By the way, we've only got 2 folks that have tweeted so far, so there's a 100% chance of those 2 people winning something. Sadly for Stefan, that means that you can only win the JetBrains license because I know where you live. So Steve, potentially you've won the IoT kit. If you haven't, then you can win the other JetBrains license. I'm sure you'd be happy with that. But you know, I will check before we sign off in a couple of minutes, just in case anybody else does tweet, because there is still potentially another JetBrains license going if Calix are still buying IoT kit. So yeah, still worth doing. But if you don't worry, it's fun to come along nonetheless. So good.
Sure, I did. I don't know if it's because I'm in hospital lying on my bed watching it on the mobile phone.
You're in hospital, are you? Oh, geez, man.
Have been since March with a badly broken leg with tib and fib and ordeal.
I know what the problem is. It's user failure. I see you now. There you are. It was my fault. So yeah, I can see you. So yeah, there's absolutely 3 people. You're in the UK as well, aren't you, Graham? So there's a potential for you to be able to win the IoT kit. So I'll wait until I've confirmed which one it is. But if not, there's a good chance actually I've got 3 licenses to give away because I've got like 3 months where I've not used them, and you get 2 a month. So I've probably got plenty of JetBrains licenses to give away. So I guess anybody that's tweeted will get one of those. So there's 3 of you. So thank you for doing that. Good. Well, I reckon it's beer o'clock.
I'm going to go downstairs and get me tea. I've got a plate of sausage and chips sat in the microwave. Oh,
nice. Very good.
Sausage and chips, nice big lashing of thick gravy on it.
Oh, perfect.
And some fresh tiger bread.
If anyone wants to smuggle some beer through past hospitals and reception, then more than
I would have thought it'd be prescribed. You know, you're in pain, man.
Yeah.
Which one are you in, Graham?
Shields.
Shields. South or north?
South.
South. I'm not going to make any promises, but I'll see what I can do.
Ward 98.
Brilliant. I want a selfie of that if that happens. That's community service for you.
So everybody completely happy with my little diatribe there then?
Yeah, it's great.
Yeah, brilliant.
Yeah. Absolutely inspirational. Yeah.
Yeah. Awesome. Yeah, great talk. Thank you. So thanks so much to Shorty or Peter Shaw if you don't know him well enough. And thanks to the folks that have come along tonight. And I know there's a few folks that have not been before as well. So thank you for coming along and supporting our little user group and listening to Shorty's fantastic presentation. We will be back next month. I can't guarantee the date, either going to be the 13th or the 27th. The 27th is actually my dad's birthday, but hopefully he'll be organising something at the weekend rather than on that Thursday for his birthday. Otherwise, I'm going to get in trouble for missing that. But other than that, we'll catch you all again soon. So thank you again.
Just quickly, for those of you who are in the Northeast, I do believe that Hainton would like me to do this in person at Tusk Park in Newcastle. Don't know when, don't know dates, don't know if it's going to happen. Watch my Twitter feed. That'll be the first place it will go out on when it starts.
Excellent.
Good
All right,
night,
thanks very much. Cheers, then, folks.
Bye.
See you again next
Thanks,
month.
then. Bye.
Bye.